we're going to see how you can create a module and what kind of things you can put in a module. Okay. So what I did, I decided to create a module called physical constants. Okay. This module contains important physics constants like the speed of light, the acceleration due to gravity, and stuff like that. So basically, that's what's contained in this module. It's a file. Okay. And this module, for a module in Python, it needs to end with this .py. So the name of the module, then .py. So the name of the file which I created was this one, physical constants, then .py. So you can see, if you've got more than two names, you want to name your thing with more than two names, then you need to connect, more than two words to connect your module. Then you connect the words with this underscore so that the whole thing is treated as one thing. So this one contains physical constants, and we're going to see what physical constants are in this particular module. So basically, this is what I did. So here I start out with this. This is the explanation of what is inside this module. Are we clear? The documentation string. So basically it says this module gives you some useful fundamental physics constants and data. That's what it does. For example, here, the speed of light. So the speed of light, this is what it is. Then I explain what this is. Speed of light, symbol is C, units meters per second. Then next, this one, gravitational constant, G, 6.67 times 10 to the power minus 11. What is this called? Gravitational constant. The symbol is G. Units, newtons, meter squared, kg squared stuff. Okay. Then there's another one, Planck's constant, 6.6261 times 10 to the power minus 34. The name of this is Planck's constant. The symbol is H, and the units are joules per that. Then something maybe more familiar, electron charge, 1.60218 times 10 to the power minus 19. I think, yeah, 10 to the power minus 19. If I'm not correct, if I'm not wrong. Then the symbol is E, then the units are coulombs. So basically you can see what I've done. I've picked some constants of physics, then I've put them in a file. Then I've given them, I'm storing them in these variables. Planck's constant, that, then the permittivity constant, then permeability constant. This one is Avogadro's constant, which is 6.022 times 10 to the power 23. Avogadro's number, the symbol is Na, then particles per mole. Then there is this one, Boltzmann constant, 1.38066 times 10 to the power 23. This is Boltzmann constant, the symbol is K, units joules per Kelvin. Then the gas constant, H.314. The name of this is gas constant, the symbol is R, joules per mole per Kelvin. Then there is this Stefan Boltzmann constant, that's another constant. Then there's the Wien displacement constant, which is that one. Atomic mass atomic mass constant, is that. Then electron mass, this is the electron mass, rest mass. Then the proton mass, 1.6726 times 10 to the power 27. Neutron mass, 1.6749 times 10 to the power minus 27 in kgs. Then there's standard gravitational acceleration, 9.8066. Then there's standard atmosphere. This is the pressure in pascals. Then there's something called Hubble constant. Then the mass of the Earth, 5.98 times 10 to the power 24. It's measured in kgs. Mass of the Earth. The radius of the Earth, 6.37 times 10 to the power 6. That's the radius of the Earth measured in meters. The density of the Earth, Earth-Moon distance, Earth-Sun distance in meters. The mass of the Sun, then the radius of the Sun. So basically, these are some constants. Okay, and as you can see, very important constants which you use in physics. I have just put them in a file like this. Then I give that file the name physical constants, then the extension .py. So this is a module which contains constants of physics. Are we clear?
Yes.
Yeah, so you open a text file. Basically, what you do is you open your computer, then you open a text file, not a Word document. No. There's a difference between a Word document and a text file. You open a text file, then you put in your stuff in that text file, because we write our computer programs using text files so that they contain text. Okay, so we save this one. So this module, where it's located in my computer, it's in the same place where the notebook is. Okay, so the module and the notebook are in the same place. So next we go back to our notebook. So we have seen what's inside this physical constants module. Okay, very, very simple. So the first thing we do is we import this physical constants module. So using the import keyword, so it's import, then the name of the module you want to import. So the name of the module I want to import is physical constants. So I run that. So the import happens. Then I want to see what kind of stuff is in physical constants. So I say help physical constants. Then Python displays what the name of the module is. It says the name of the module is physical constants. Then what does it do? What is it used for? The module gives some useful fundamental physical constants and data. Then what kind of information is inside this module? So as you can see, Python has decided to arrange this information alphabetically from A all the way up to W. So it's not, the information is not displayed the way we have displayed it ourselves. So it starts with atomic mass constant, which is that, then Avogadro's constant, which is this, Boltzmann constant, Earth mass distance, Earth mass, the mass of the Earth, then Earth moon distance, then the radius of the Earth, Earth sun distance, then electron charge, electron mass, gas constant, gravitational constant, Hubble constant, the neutron mass, permeability constant, permittivity constant, Planck's constant, proton mass, speed of light, standard atmospheric pressure, standard atmosphere, the standard gravitational acceleration, which is our G, then Stefan Boltzmann's constant, then mass, the mass of the sun, the radius of the sun, then Wien displacement law. As you can see here, what the data, that's what's displayed. The comments about what this unit, what this constant is, this stuff, everything after this hash sign, because this is a comment. Okay, this is a comment. The comment stuff bit where you're giving more explanation about what this thing is, this is not displayed. Python doesn't show this. Are we clear? It only displays this bit. Okay. I don't know if we can, yeah, but basically for now. Are we clear on this bit?
Yes, it is.
Yes.
Okay, so the next thing is, if you want to access one of these constants, so there are two ways to do it. In a module, when you create a module, your module can have either variables, like in our case here, where it has got only data. Those variables are stored as data, or it can also have functions. So if you've got a module, you start with the name of the module. Then if you want to access the function, the name of the function, you put the name of the module, then you put a dot, then the name of the function, or the name of the module, then you put a dot, then the name of the variable. So in our case, our physical constants module contains variables. It doesn't have a function. Okay, so in this case, if I want to access, for example, Avogadro's constant in this module is this one. That's the variable which is there, Avogadro's constant. So I will say the name of the module, which is physical constants. Then after that, I put a dot, then this Avogadro's constant. Then I get that. Are we clear? So you access the value which is stored in Avogadro's constant, the variable Avogadro's constant. Is that clear?
Yes, it is.
Next, we move on to, if you want to access the electron charge, if you look at this list, electron charge is stored as electron then underscore charge. This is where the value for electron charge is stored. So you would say physical constants, which is the name of the module, then after that you put a dot, then electron charge. So that's how you're going to access the value of the electron charge. Then there's proton mass. If you want to access the proton mass is stored as proton here. So proton, then underscore mass, like that. So you start with the name of the module. This is one way of accessing values. So you start with the name of the module, which is physical constants, then proton mass, like that. Then if you want to access this constant called Hubble's constant, so you look at this list, Hubble's constant, where is it? How is it stored? Here it is. That's how it's stored, Hubble's constant. Then, so you start with the name of the module, physical constants, then you put a dot, then Hubble's constant, like that. So you get the value for Hubble's constant. However, you can clearly see that having to type physical constants every time you want to access a value is inconveniencing. So sometimes Python also allows you to import your module as something else. So in this case, instead of importing all the time writing physical constants, we want to import this module physical constants as PC. In short, basically a shortcut for physical constants. So I want to say, instead of writing physical constants, I want to be writing PC. So I want to tell Python, say, going forward, I want to re-import this physical constants module, but I want to import it as PC. So I say import physical constants as PC. So because I want to avoid having to type this physical constants all the time, it's quite long, okay? So I want something short. So I use an alias, which is PC here. Then now, instead of writing physical constants, I can just say PC dot electron mass. Then it gives me the electron mass. I can say PC dot speed of light. Then I get the speed of light. I can say PC dot gravitational constant. I get the gravitational constant. I can say PC dot electron charge. Then I get the electron charge. I can say PC dot Stefan Boltzmann constant. Then I get access to this Stefan Boltzmann constant. So here we are talking about, with a module, how do you store your variables? Because there are some variables you might want to use every now and then in your work. So how do you want to store them? You store them in a module. So you open a text file, then you give it a nice name, then you give it an extension .py, then you put your stuff there. After you put your stuff there, you get this text file, you put it in the same location as your notebook. Okay. Are we clear so far?
Just repeat that one, which you are just from saying.
Which one?
On importing.
The importing thing is the same thing. The only thing I don't, you see, here I'm having to type the name, the whole name of the module, physical constants dot something, okay? But I don't want to do this because I'm typing too much. So I want to import this module as something else. For example, you have your names, your full names, but maybe your friends you went to school with, there's a nickname they used to call you. Okay? So these friends of yours might not want to call you using your actual names, but they've got a nickname they use. This is the same thing. Instead of saying physical constants, we are telling Python, this physical constant module, I want to call it using a nickname called PC, which is short for physical constants. Are we clear?
Yes, in short, you have an alias.
Yes, it's an alias. PC is an alias. I can ask for help on PC, say get help on how to use PC. and let's see what you get. It's an alias, so basically what I have, which is a nickname. So I say help with PC. I say PC. This is what I get. So you can see PC actually stands for this. You get the same information, the physical constants module. Then the name of the module, which is being referred to as PC, is physical constants, and it's the same information which we have. So we have given this module, physical constants, a nickname, PC. So whether you use the actual names of the module or you use the nickname, you start with the name of the module or the nickname, then you put a dot, then the constant or the variable you want to access. So that's like here, electron mass. So electron mass is here, electron mass. So I'm not using physical constants. I'm using the nickname. I'm using PC, then I put a dot. Then I'm telling Python, look in this module called PC. Then in this module called PC, show me the value for electron mass. That's why you see that. Look at this module called PC, which is the nickname for the physical constant module. Then show me the speed of light, the value for a variable called speed of light. Look in this module we are calling PC, nickname PC. Then show me the gravitational constant. Look in this module we are calling PC. Then show me the electron charge. Look in this module we are calling PC. Then show me the value of Stefan Boltzmann constant. That's what you're doing. Is this clear?
Very clear now.
Yes. So basically this PC is a nickname or an alias for our physical constants module. So you could do this. So we're trying to show different ways of accessing the data which is in your module. You can actually use the whole name of your module, or you can create a nickname, or you can also do something else. You might not want to access everything. Okay? You might want to only access certain variables in your module. So if you want to access only certain variables in your module, you tell Python the following. You use the from keyword in combination with import. So you say the following to Python. From, after from, what comes is the name of the module you want to import things from. So you're saying from physical constants. So you're telling Python, look in the module called physical constants. Then after you look in there, import the following. Import the standard gravitational acceleration, import Stefan Boltzmann constant, import neutron mass, import electron mass. So when you do this, when you say from a module, import certain things, like in this case, we want to import the acceleration due to gravity, Stefan Boltzmann constant, the neutron mass, and the thing. In this case, when we run this, we no longer have to put something in front. Okay? Once you do that, then you can just say standard gravitational acceleration without putting something in front. Now we're not putting anything in front. So you just say standard gravitational acceleration, then you get the value. Neutron mass, then the value gets displayed. Stefan Boltzmann constant, then the value gets displayed. Electron mass, then the value gets displayed. If someone just sees electron mass, the slight disadvantage of this is when someone looks at electron mass, they have to follow this. They have to understand this. They have to know that these values come from this piece, this module. Okay? They come from this file. Are we clear? This is this is much neater, but it doesn't show you, like when you just say electron mass, it doesn't right there and then when you're using it. The information about where this electron mass is coming from is a bit not shown here. You have to go back and look at this line to show that, to see that, oh, the electron mass and all these other things were got from this file called physical constants. Are we clear?
Yes.
Is that clear? Okay. The other thing also is you can actually make a nickname for a variable in a file. You can actually make a nickname for a variable in a file. Okay? For example, the speed of light. We know that in physics we commonly represent the speed of light as c. So you can say the following: from physical constants, import speed of light as c. So you are telling Python, look into a module called physical constants. In this module called physical constants, find a variable called speed of light. Now I want to use this speed of light. Then this speed of light, give it a nickname, and we are giving it a nickname c. So when we do this, that's good. Then we can just say c. When you say c, it shows the speed of light. Is this clear? You can give a nickname to a module, but you can also give a nickname. You can also give nicknames to the things which are in the module. Is that clear?
Yes, it is.
Rachel?
It is clear.
Okay, next, again, you can say from physical constants, import electron charge as E, because electron charge in a physics textbook is represented as E. Then next you display E and you get your electron charge like that. Stefan Boltzmann constant in physics textbooks is represented as K, so you can say from physical constants import Stefan Boltzmann constant as K, like that. Then you display the value of Stefan Boltzmann constant, you get that. Or the acceleration due to gravity, the standard gravitational constant, standard gravitational acceleration, not gravitational constant, the gravitational acceleration. So this one we say from physical constants import standard gravitational acceleration as g. Okay, because we use g for gravitational acceleration, then that g gives you your 9.8066. Is this clear how these things are working? This is how you access your data from a file, and you have got a lot of choice on how you want to access your data. Absolutely a lot of choice. Then the gas constant error, so you say from physical constants import gas constant error, like that. Then you display your gas constant error. This is how you know it, because in the textbook your gas constant error is capital R, like that. You can also just tell Python, well, I want everything which is in this module. Now, how do you tell Python you want everything which is in the module? Well, you have to import in a certain way. You have to use a star. So you say from physical constant import star. You are not specifying what you want, but you're telling Python I want everything. Okay? Are we clear? When you put a star, you're telling Python you want everything which is in a particular module. Is that clear?
Yes.
Okay, so when we do that, once we do that, then we can just, after we do this, then you can just be saying Hubble's constant, you get a value, gas constant, you get a value, Planck's constant, you get a value, Boltzmann constant, you get a value like that. So basically, that is how you get data from your, from your module. You need to import the module in one way or another. You have got choice on how you're going to import these things. So you choose exactly what the best way is for what you're doing. So that is about this physical constants module which I created. I just got a textbook, a physics textbook. Then I went on the page where there are those constants. So I decided, okay, let me get these constants, let me put them in a file. Then let's see. And that's how we created this. Because I know you need to use these maybe when you're doing your physics stuff, or you're doing your lab and stuff like that. So you need some of these, then you put your things in a file. then you give your file a name, a suitable name, which gives you an idea about what's in that file. Then the extension is .py. That's how we store our modules. There's another module I created, a simpler one. This module is called mechanics. So basically this module has got some functions which try to work out things. Okay, and now I want to show you what this one has. Where is it? Mechanics. This one here. Okay, mechanics. So this is what it does. So this one, okay, make a change. So that's the explanation of what this module has. Okay. So this one contains some functions. As you can see, I have defined some simple functions. For example, I say define def. I tell Python I want to create a function. The name of the function is speed. Then what does the function take? It takes the distance covered. It also takes the time taken. So this is going to work out what is the speed in meters per second. Then there is distance. This function called distance. I give it the speed, I give it the time, then it's going to work out what the speed is by multiplying the speed times the time taken. That's how it's going to work out what the distance is. This one, the one for speed, is going to divide the distance covered by the time taken. That's how it's going to work out the speed. Then there is this one, average speed. This one for average speed, it takes the final speed, the initial speed, then the time taken. And how does it do that? 0.5 times the final speed plus the initial speed multiplied by the time taken. It gives you average speed. There is the acceleration. It needs the final speed, the initial speed, and the time taken. So how does it do that? Basically, this is the final speed minus the initial speed divided by the time taken, like the way you work out your normal acceleration. There is also another one here. This one works out the force. For you to work out the force, there is mass. Then there is acceleration. And how does it work out the force? Well, just multiply the mass times acceleration, then you get your force. Then there's a gravitational force. This one works out the gravitational force. This function works out the weight. So for the weight, you just give it the mass. And that mass is multiplied by 9.8066. Like that. There is also something called linear momentum. There's friction. There's impulse, there's wake, there's kinetic energy, gravitational stuff, and power. All these functions basically are based on actual physics formulas. So I just got the formulas, then I turn the formulas into functions. Are we clear?
Yes.
Yes. Can you see what I did? I just got the formulas, then I turn them into functions. That's all. Here. Mass times acceleration, so you get that. So basically this is the so-called mechanics module. So basically it depends on what you want to do. Depending on what kind of thing you're trying to do, you can create your own functions. Then after you create your own functions, these functions you put them in a file like this, mechanics. Then that's it. I save it. So now I'm going to go to here. So I'll say fine, okay, fine, import mechanics. So I import mechanics. I've imported it. Then I ask for help on mechanics. Then Python opens this file, this mechanics thing. Then it says help on module mechanics. So the name of the module is mechanics. Then what does this module do? This module stores some useful mechanics functions. So it starts with the first one, the function. Now it's showing, because Python knows whether you're talking, what you have in your file is just variables or functions. So Python detects, oh, there's a bunch of functions here. That's why it says functions here. So the first one is acceleration, which accepts final speed, initial speed, then time. So this is how you're supposed to give the information. Then it's going to, the explanation is it's going to work out the acceleration and like that. Then there's average speed, there's displacement, there's distance, there's final velocity, there's force, mass and acceleration. It retains the force in newtons. There's friction force, gravitational potential energy, impulse, kinetic energy, linear momentum, power, speed, torque, weight, like that, all this stuff. So basically, these are the functions which are in that module, which I showed you. Okay. Is that clear?
Yes.
Yeah, so you can just get your physics. There are so many physics formulas. You get your physics formulas, then you put them in files so that when you're doing your physics things, you're actually using files which are on the computer than you actually writing out stuff. So here we've got a problem. It says a runner makes one lap around a 200-meter track in a time of 25 seconds. What were the runner's average speed? So we have a guy who covers 200 meters in 25 seconds. So we're asking for his average speed. So this is basically how you try to work out, say, okay, what's the data here? The distance is 200 meters. They have covered, the time is 25 seconds. This is not Python. The Python starts from here. You know that there is a function called speed somewhere here in this module mechanics. Speed, where is speed? This speed function needs the distance covered and also the time taken. Then it's going to give you what the speed is. So we import it. So we say from mechanics, import speed. So we run that. Then we say speed, the distance covered is 200 meters, the time taken is 25. Then what do we get? It gives us the speed. There. 8. That is 8 meters per second. Are we clear?
Yes, we are.
Yeah, so you can actually do your physics things with Python. When you get your functions, you put them in a file nicely, then you can use your functions like that. Okay. Then here, a car moving at 30 meters per second slows uniformly to a speed of 10 meters per second in a time of 5 seconds. Determine the acceleration of the car. So basically the initial velocity here is 30 meters per second, the final velocity 10 meters per second, the time taken for this change is 5 seconds. So again, you're looking for the acceleration. The acceleration function is this one here. So you need to give it the final speed, the initial speed, and the time taken like that in that form. So here we say from mechanics, import acceleration. So you import your acceleration, then we say acceleration, the final speed is 10, initial speed 30, the time taken is 5 seconds. So when you run that, it gives you acceleration as -4 meters per second squared. You see how this thing is working? You don't have to you don't have to make very complicated functions. For you to get started with these things, you have to make functions which you can actually use. So as long as you're using your programming language for your things which you actually need to do, then that's how you get mastery of a language. Then here, a track starts from rest and moves with a constant acceleration. So a track starts from rest and moves with a constant acceleration of 5 meters per second every second. Find its speed and the distance traveled after 4 seconds. So a track is starting from rest, which means the initial velocity is 0 meters per second. The acceleration you've been given here is 5 meters per second squared. Then the time it moves for is 4 seconds. So you want to find the final velocity. There is a function in this thing here called final velocity. This final velocity function requires the initial velocity, it requires the acceleration, it requires the time taken. Okay, because this final velocity thing is based on that formula v is equals to u plus at. You know that formula?
Yes.
Yes, it's based on that. It's based on that. V is equals to u plus at. If I show you the mechanics thing for final velocity, here, final velocity. So you can see here, initial velocity plus the acceleration times the time taken. So basically, v is equals to u plus at. So it's based on that. Okay, so these things are quite very straightforward. But once you have your function, then you just putting things there. So here, so we import from mechanics, we import the final velocity. Then we want to get the final velocity. So the final velocity is equal to, so we final velocity function. Then for the initial velocity, we put that's 0. The acceleration is 5. The time taken is that. So we want to find the final velocity. So the final velocity in this case is going to be 20. Okay. Then also the distance covered. So we say we're looking for the displacement. So we say for mechanics, import displacement, that. Then the other thing which is not very obvious, you can ask after you import something, you can ask for help on how to use it. You can say help final velocity, so that you see exactly how to use something. Final velocity, like that. So here, so you say final velocity, the way you use final velocity is the first value is going to be the initial velocity, then the acceleration, then the time taken. Then what you're going to get, the value you're going to get is going to be in meters per second. So you get an explanation of how to use a particular function. So here, so I would say get help on final velocity. So this is very useful, that you try to reassure yourself on how a particular function is used, like that. Very straightforward. Then also you probably also need help on the other ones, the ones we've used before. On acceleration, you can say get help on acceleration. So help on how to use acceleration. Acceleration there. So acceleration, so you put in the final speed, then the initial speed, then the time, like that. Then you get your thing. There's also the other one, the speed. So you can say help on speed. So speed, get help on speed. So you say help on speed, how to use speed, that. Are we clear?
Yes.
Clear.
Yeah, so these things are not difficult, and this is what we're going to need as we try to solve our physics problems, because these physics problems, we have to change these physics problems into something which a computer can understand. Okay, then after the computer understands it, then we get our answers, like that. So here we're on displacement. So get help on how to use the displacement function. Displacement. So help displacement. There. So for displacement, you put in the initial speed, then you put in the acceleration, then you put in the time. Because this, why does it work like this? Because I'm using the formula S is equals to ut plus half at squared. Okay? For me to get the distance which has been moved. Are we clear?
Yes.
Okay, so that's on the displacement. Then the next function I want to, like when you want to work out, so find the weight of a body, find the weight on Earth of a body whose mass is 3 kg. So you've got a body on Earth whose mass is 3 kg. So where are we going to get the weight from? The weight function is in mechanics. Okay, there is a function called weight in mechanics. So we say from mechanics, import weight. Then how do we use this weight function? So we just say, So we just say help. After we import weight, import something, then you want to figure out how to use it. So just say weight, then you put the mass there. So I say weight, then the mass is 3 kg there. Then in turn, I get the weight in newtons, like that. Are we clear on how these things are working?
Yes.
Yeah, so
It's clear.
basically that's how this whole thing flows. Then here there is a 20 kg object experiences an acceleration of minus 2.2 meters per second every second in the x direction. Find the resultant force. So I'm trying to work out what the force is. So I know the mass of the object, I know the acceleration. So I can go and import the force function, say from mechanics, import force. So I do that. Then I ask for help on how to use this function force. So I want to ask for help on how to use the force function. So I say help force, like that. So it says, okay, fine, there's a function called force, and how is it used? To say force, then you put the mass, then you put the acceleration. So that's what I do here. Say force mass equals to 20, acceleration equals to minus that. Then I get the force. The force is minus 45 newtons. Are we clear?
Very clear.
Yes. Then the last question, I think, yeah, the last question, question 6. A constant force acts on a 5 kg object and reduces its velocity from 7 meters per second to 3 meters per second in a time period of 3 seconds. So there's a force which is acting on a 5 kg object, and the velocity of the object reduces from 7 to 3 meters in 3 seconds. So there's an acceleration which is happening, and there's a force which is causing that acceleration. So we can work out the acceleration, then we can find the force. Okay? So in this case, import acceleration from mechanics. So we say from mechanics, import acceleration. We do that. Then we can ask for help on how to use the acceleration function. How to use the acceleration function. So you say so help acceleration. So how do you use acceleration function? So basically you say acceleration, the final velocity, the final speed, the initial speed, then the time. So in our case, the final speed was 3 meters per second squared. The initial speed 7 meters per second, then the time 3 seconds. So here the final speed is 3, the initial speed is 7, then the time is that. Then whatever the acceleration is going to be produced, we don't want to print it out like the way we've been doing here, like displaying it like this. We want to store it in a variable called accelerate. Then we print out that variable because we want to use this variable accelerate to work out the force. Okay, so that is basically us storing the value which we get from a function in a variable. Then if you print out accelerate, that's what we get. So this is the acceleration which we get. Then we want to work out the force. Now if you remember very well, I think we already imported the force, which is here. So the import of the force was already done, so we don't need to import again here. So we can just work out the force. You can ask for help on how to work out how to use force. You can say help force, but you don't have to import things twice. So for force, you need mass, you need acceleration. So the mass of the object is 5 kgs, right? And the acceleration is what has been stored in accelerate here. So we say force is equals to 5 kgs, acceleration is equals to accelerate, and when you run that, you get this force as the force which is causing the object to slow down. Are we clear?
Yes.
Yeah, so basically this is it when it comes to modules. You can create your own modules, or you can use other modules the same way we have used this tool, like this. Do you have any questions?
For me, it's clear.
Rachel?
Clear, sir.
Okay, so I also hope that the video recording, I tried with the other classes, it worked, so I know where I made a mistake with yesterday's class. So I'm sure this one is going to come out just fine, and I'm going to upload it this evening to YouTube so that you can see.
Okay.
The other thing I'm also going to do is I will try to send the notebooks and the PDFs for all the things we've been looking at on modules. Okay, so that you can have something to work with. All right, so unless there are any other questions, we'll come to a stop here. The other thing is I would like us to start meeting over the weekend so that we can shift these classes, the ones we have at 20 to 21. I want them to, because we're only meeting for 3 hours now, right? I want to shift these 3 hours to Sunday afternoon.
Sunday afternoon, like what time?
From 14 to 17.
14 to 17.
Is that okay?
Maybe 14. For me, maybe 15. Because I knock off at 13 from church. So for me to reach home.
Okay, fine. So then we can do it from 15 to what?
to 18.
15 to 18.
Okay. Yes.
Brian, how is that? 15 to 18?
That's fine with me.
Okay, so that's what I want to do. So the plan is we want to shift these things so that we just be meeting over the weekend, because we have got
just once a day.
Yeah, just once a day.
Okay.
Then instead of meeting 3 times in
a week,
we just meet once a day.
Okay.
Yeah. So basically, can we start this Sunday?
This Sunday?
What's happening? Or people still have to organize themselves. I don't know.
Yes.
Okay, then if we can't start this Sunday, it means that we have to continue meeting next week, Monday, Tuesday, Wednesday, then we start Sunday.
Yes.
So our next week, Monday, Tuesday, Wednesday, is going to be the last time we're meeting during the week.
Okay.
Then we're going to move to the weekend.
All right, that's okay.
Yeah. Okay. So basically that's the other thing I wanted to talk about. Unless you guys have got something on your end, I don't have anything this side. So right now, this is topic number 9 we're doing.
Yes.
So this is topic number 9, and you're going to go up to topic number 15 when it comes to this programming stuff.
Okay.
So we're getting closer and closer to the end of this programming stuff so that we can actually now start doing our computational physics.
Okay.
Yes. So this is topic number 9. Hopefully next week we're going to do topic number 10 between Monday and Wednesday. Then over the weekend we move on to topic number 11. We discuss. By the time we reach topic number 15 or 16, then I think, in my opinion, we would have done everything you need for you to successfully tackle this course, so that I can actually start teaching you the computational physics which you need to do.
Okay.
Yes. Okay. So that will mean we are now in what? We are now in March. So March halfway. So hopefully, I'm thinking probably by end of April. Yeah, by end of April we should be done with this computational stuff. Then the other thing is, over the weekend, when you meet over the weekend, we'll be covering a topic. So when you start the computational physics over the weekend, the target is to finish a topic.
Okay.
Yes. All right, so we're done.
Thank you. Good night.
Good night.
Thank you so much. Good night.
Cheers.
Thank you.
All right.
Bran.